In this presentation, you will learn about how to combine two or more forces to find the single force that will have the same result. This single force is called the net force or resultant. This presentation will focus on how to find the resultant when the angle between the forces is 0 degrees or 180 degrees. In his second law of motion, Isaac Newton discovered an equation that allowed you to predict the acceleration that will be produced when a net force acts on a mass. The acceleration depends directly on the size of the net force and indirectly on the size of the mass. This equation tells us that the larger the net force that acts on a body, the larger the acceleration it will produce. It also shows us that the more massive a body is, the more difficult it will be to accelerate. This presentation focuses on how to calculate the net force on an object. For example, the net force when 5 Newton forces act in opposite directions equals 0 newtons. Since the net force equals 0, these two forces would not cause an object to accelerate. In the second example, the net force is 40 newtons east. Both these examples illustrate that when forces act in opposite directions, you find the net force by subtracting the forces. In the next few lessons, you will learn about the rules that we use to combine two or more forces to find the net force or resultant. Force is often defined as any straight line push or pull. I've always thought that this was a very limited definition of force and that a third type of force should be added to this definition. Along with a push and pull, I add a third description. It's the kind of force that stationary objects like tables and walls exert. Tables and walls resist. So forces either push, pull, or resist. In the English system of measurement, force is measured in pounds, and in the metric system we use the units newtons. This is not a very scientific definition, but a newton is about the weight of an average apple. Forces are vectors. This means that a force requires magnitude and direction to fully describe it. Scalars like temperature, time, and distance do not need a direction to fully describe them. When solving problems and drawing pictures, forces are represented as arrows drawn to some selected scale. For example, if the force vector drawn here was 4 centimeters long and each centimeter represented 10 newtons, we would say that the force vector represented a force of 40 newtons east. Remember, forces are fully described using magnitude and direction. In the beginning of this presentation, I talked about how the net force on an object determines its acceleration. Another term for net force is resultant. The resultant is the single vector that will have the same effect or result as two or more vectors. So remember, net force is the same as resultant. When two forces are acting in the same direction, like the picture shown here, we say that the angle between them is 0 degrees. To find the net force or resultant, when the angle between the forces is 0 degrees, we add the forces. The resultant of these two forces is 9 newtons east. Forces are vectors, so we always include the direction in our answer. It may not be so obvious that the angle between these two forces is 0 degrees, but remember, the angle is 0 degrees when the forces act in the same direction. So even though the second vector drawing looks different than the first, they have the same resultant. So the rule is when two forces are acting in the same direction, the angle is 0 degrees and we add the forces. When two forces are acting in the opposite direction, we say the angle between the two forces equals 180 degrees. To find the resultant or net force, you subtract the smaller force from the larger force. The resultant takes on the direction of the larger force. So whether they are two opposite pulls or two opposite pushes, the angle is 180 degrees. In the example here, the resultant is 40 newtons east. When two forces act in opposite directions, the angle is 180 degrees. The resultant is 40 newtons east. So the single force that would have the same result or effect as these two vectors is 40 newtons east. Let's do two more examples. In the first example, the angle is 180 degrees because they're going in opposite directions, and the resultant is 10 newtons west. In the second example, The resultant is 6 newtons east. Remember, the resultant takes on the direction of the largest force, and the largest force is 8 newtons east. In this lesson, you learned that a force is a push, pull, or resistance. Forces are vectors, which means that they are fully described using magnitude and direction. When you combine 2 or more forces into a single force that has the same result, it's called a resultant. When 2 or more forces act in the same direction, the angle is 0 degrees, and you find the resultant by adding the vectors. When forces are acting in opposite directions, the angle is 180 degrees, and you find the resultant by subtracting the smaller force from the larger force and using the direction of the larger force as the direction of the resultant.